And there is one more technique that does help us do managing divergences between test and training. And it tries to score some things. Okay, so let's look at that technique, which is called the bootstrapping. So what people usually do is they will say, look, I want some sort of a scoring method so that I can do model evaluations. These model evaluations must factor in both my training and my test set considerations. Okay, so that is kind of the space where we are in as we look into the bootstrap. So a general algorithm for bootstrap is like this. A given n data points in X, which is my training, I would split it. See the split here? 50%. Train, test split, 50%. Okay? And I'm setting up some iterations for me to operate for the bootstrap. My first step, I obviously run into iterations, the loop. What I do is, as I go into the loop, I'll be sampling n points with replacement from my X and store it in my temporary space S. Okay? Important thing to note, n points with replacement, because the strategy is with replacement only, bootstrap shines. If you take without replacement, bootstrap starts to break statistically also. So be careful. Next, we will apply the train test split on this S. We are never touching the train test split on X. We are never, in fact, operating on that space at all. Always our goal is train test split 50%, 50% on my smaller segment, which was sampled points. Store my training data and training set, train on my training data, evaluate my model on the test set. Evaluate my model first on the test set, and then the second one is on the S, which is the overall data set. Okay, store the results to the list of what I got here. So I would have got some evaluated data. I do a 1 minus of the evaluation data for both my training set and also for my overall set. When I do 1 minus, it basically gives me error. Okay, so that's why I'm doing 1 minus. So if I get my metrics is, let us say, accuracy. Then if I got 80% accuracy, then 1 minus would be 20%. So 20% is an error. Okay, so that's what it really is referring to. We would return the average of my error from a training data set, which is the error fit. We will also return the average of the bootstrap. Bootstrap means the entire store, the temporary store's error that we have for our model. Okay, so these two errors we are going to be returning. The average we will return. You can also return the median. In fact, you will have the entire list of the errors for you to do any distribution work if you want to do. Okay. Then according to the bootstrap strategy, the error from the bootstrap for a given model is this equation. 0.368 times the fit's error and 63.2% the bootstrap's error. This overall error is called the error from the bootstrap and is also called 632 plus bootstrap.